you guys have all done this. You guys have all done this before. You guys have all done this at the very beginning of the chapter, whenever you had to find a theta value. When you had to find a value of theta, what you would do is you were working with trying to pick out which trig function to use given some specific information, and solve basically a one-step equation. So in this case here, if I had to figure out the angle value of theta, I know the value opposite me, and I have my hypotenuse. Which trig function is that looking for? Sine. So this means that in my calculator, I'd have the sine of theta is 3/5, and then I would do the inverse sine of theta to figure out that value. So in essence, what you were doing is you were asking the calculator to figure out, hey, calculator, how are you? And then you say, that's what you do. And no, we're not flirting with the calculator. Boy, I just leave it alone. Hey, calculator, what angle has a sine value that's 3/5?
Hold on a second, I'll look. Beep, 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 boop.
You press the buttons and you got an answer. So, I'm an idiot. Anyway, that's what you were doing. But now you're going to do that without using a calculator. So you have to know some stuff. Inverse sine of theta. What we're going to do today is we're going to work on how do you set up and find out which angles have a sine value of root 2 over 2 or 1 or something along those lines. But where do you have to look for them in terms of not being able to use a calculator? Right. Not so much the unit circle, but we're going to use portions of it. So what happens is, when we're looking to find values of sine, we're going to look for values of sine between two spots. We're going to look at them, we're going to search for values of sine where sine is between pi over 2 and negative pi over 2. We're going to look through all values of sine that have value that between, well, or if you want to think of it as 90 and negative 90. I don't want you guys to think that we're looking for something that's, see how we're just starting at the top and working our way down? By doing sine values, you're looking for sine values that are between 90 degrees, down to 0, and then down to negative 90 degrees. Because we're not going to be trying to find sine values of angles that are obtuse. We're only going to look for sine values of acute angles, or a 90 degree. Because you know what the sine of 90 is, because it lies on what we call the quadrantum. The ordered pair at 90 is 0, 1. Here it's 0 and negative 1. At 0, it's 1 and 0. So a couple of things that you know right away is that an angle that has a sine of 1 is 90 degrees. Because sine is opposite over hypotenuse. At 90 degrees, your opposite and your hypotenuse are always the same thing. That's why it's equal to 1. Okay. This also starts to show you that as we get into this, oh, that's right, it's not next week, it's going to be SAT. Well, whatever. Sooner or later when we get into this, if you start sine value at 0, and let's say you're going around the circle, you move up to 1 when you hit 90 degrees. It goes back to 0 when you're at 180. It drops to negative 1 at 270. Full circle, it comes back here. Sine oscillates in the XY grid as it rotates around the circle. It's crazy how this stuff goes between two-dimensional and planes like this back and forth. But these are some of the reasons why these angles work. Okay? What's that? Yes, ma'am.
So, like that, like if that was like a 3D model, would it basically kind of be like a really stretched out slim?
Yeah. Mm-hmm. Yep. Yeah, it could. And then you can change the frequency of it by how fast things can oscillate, by the amplitude of the period. We can just mess around with all that and see how quickly things can move. Right. So what's going to happen here is I can ask you this. The sine of something, what's the inverse sine of negative root 2 over 2? And you're going to tell me what angle have. That basically means what angle has the sine of negative root 2 over 2. Oh no. Well, to make it easier, I say, there's only two different triangles you have to worry about. It's either a 30-60 or a 45. Always those pesky triangles, I know. If it wasn't for those pesky triangles, I would have gotten away with it.
Well, is that a 40 angle?
It has to be. It has to be, and that's the idea. Exactly. So it has to be a 45-degree angle. Now, is that 45-degree angle, when we're looking at it, is it going to be going up? No, it's going to be moving. It's got a negative because it's negative. So that means what I'm going to do is think about it. All right, this has to have a value of, it moved down for this, sorry. It's going to be a 45, 45, 90 with a 1, 1, root 2. The sine value means it has to be 45 because the opposite was 1, the hypotenuse is the root 2. So it moved down 1, here's your root 2. So this has to be 45 degrees negative, but in radians, that means your answer is negative pi over 4. Because you moved down, because it's negative. That's what you're doing here. You're only going to be able to find it within certain parameters. You're not going to have to worry about figuring out what angle has the sine of, it's always going to wind up that. Yes, ma'am? I'm going to ask you for radians. I'll probably ask for both radians and degrees, because radians are a lot more important than degrees. No offense to degrees, but radians are rad. Yeah, then degrees suck. I know.
How many radians is that?
17. Okay. The next one is cosine. Okay. What this is asking us here, what angle has a sine of root 2 over 2? Sine, when you're looking to figure out what angle it is, you're only looking between pi over 2 to negative pi over 2. So that means it's negative, it has to be down here. Being a root 2 over 2 means it has to be a 45, 45, 90, which means it has to be negative 45, which means it's negative pi over 4. That's all that meant. No, it doesn't work as well. Because unit circle, you can use unit circle, but what's going to happen is that it's not going to give you what we're looking at as a negative reference angle. Trust me, it doesn't. It's not as goofy as it sounds. Right?
Wait, how do you, isn't there a formula for converting degrees to radians?
Yeah, why waste your time?
This next one.
Okay.
Like, I would figure
No. One thing you're going to remember: 45 degrees always has a 4 in it.
Yeah. And if it's only one, then it's just one.
Right. And then the 30 degrees is going to be 6. A 60 degree is a third. That's all it is. And I know it sounds like, oh, that's all it is. But just remember, you're going up from 30 to 60 is 1/3 up, so it's 2/3. So you just bring it up, so that's where you get your 6. Yes, ma'am. Let me show cosine first, okay? Cosine. Cosine is found between 0 and 180. You search for cosine angles. You're going to search for cosine angles between 0 and 180 degrees, or between 0 and pi. Which means, again, cosine can land on one of 3 quadrantals. So you know that the cosine at 0 is 1. The cosine at 90 is 0. cosine at pi is -1. Yes, ma'am?
So if you have to turn inverse of sine and then negative root 2 over 3 or whatever, will you get the answer that you came up with to like check it? Or
What do you mean? Oh, if you, all right, so if you take the sine of whatever angle you find,
no, I mean of what they originally gave you. Like give us like inverse of sine.
okay, what's the sine of pi over 4 or something like that?
Yeah.
It's kind of working, it's not that, all right. The sine of pi over 4 is root 2 over 2. What angle has a sine of root 2 over 2 is pi over 4. You're going in either direction with them. So yes, I see what you're saying. You could check it by hitting sine of 45, and you should get the decimal equivalent of root 2 over 2. If you do this in a calculator, and you're using it in degree mode, you'd have to type in the sine of negative 45 degrees. And then it should come up with negative, decimal equivalent of negative root 2 over 2 then. Because if you type in, let's see, if you type in, what would that be, 315? As you're coming around, it'd be 315, correct? Yeah. That gives you the reference angle of 45, and then sine is negative down there, so it still should give that to you. But by not having to go and use all those different reference angles, what we're doing is we're eliminating having to find the reference angle by just looking for what is the only possible reference angle so that way it mirrors itself through the other quadrants. So what happens here is that, let me go to this real quick. If you're doing sine, sine is positive here and negative here. If I'm looking for it in the first quadrant, that theta value is always my reference angle. That covers positive reference angles here and here. If I'm finding that it's a negative, that's my reference angle going that direction, which covers me to go back that direction as well. That's why we only worry about those two quadrants. So when we switch gears to cosine, cosine's positive here and negative there.
So if it were negative, it's like the last one where it was negative, it could have been at the upper left-hand corner.
Correct. You're only gonna search, yeah.
Okay.
Because your answer is gonna be negative pi over 4. You're not gonna have to spin around to another quadrant to get you there, okay? What you're getting at is a little bit more complicated for probably maybe tomorrow. I think we'll have a little bit of time to start that when you're actually solving the equation, because there's gonna be different ways that we word it to find different values within each quadrant. Because yes, sine's negative in 2 spots. So you have 2 answers that you could happen. But we're just trying to find a singular angle, what angle has, we're just bouncing to that negative. All right. There's a whole set of parameters we'll add to it tomorrow. All right. So cosine. Cosine is the one that'll give you, it goes acute first quadrant, and then second quadrant cosine becomes obtuse if you really start thinking about it. Because in the second quadrant, you're going to get the reference angle below it. And that gives you obtuse angles coming around. So what happens is, you're going to see what angle has the cosine of negative root 3 over 2. It'll ask you that specific question. Well, knowing that cosine is negative in the second quadrant, and that's where you're going to be searching through, all you would do is sit there, okay, root 3 over 2, root 3 over 2. So my theta for cosine, that means I'm looking at a root 3, my hypotenuse is the 2. So what theta looks at a root 3 and has a hypotenuse of this? 60. Okay. Wait, did I drop that wrong?
Yeah,
I did, didn't I?
it's the 3 on the
It's
x-axis.
Yes, yeah, thank you. I do the sign. Sorry about that. As I was saying, like, wait, what did I do wrong? It took me a second to figure that out. So that has to be 30 degrees up. But what you're doing is, you're not looking for 30 degrees up. You're looking at it coming to the terminal side. So that would be how many degrees? 150. So this would be 150 degrees, or radians. 30 degrees up is up pi over 6. So that means it's coming over, you are at pi over 6, very good. That's what it's doing. It's asking to figure out where does that reference angle get placed to make it work. Okay? Now, with cosine and with sine, you could get values that lie within the quadrant. Yes, ma'am.
Okay, so the numbers we're finding, like for this one is like pi, or 5 pi over 6,
Mhm.
that's the reference.
Yes.
Okay.
Well, I'm sorry. 5 pi over 6 is not the reference angle. 5 pi over 6 is the angle. What angle has the cosine value of negative root 3 over 2?
Oh, so it's like we're basically inversing what we write it down.
Yes.
Okay.
Yep, exactly. That's exactly what it is.
So then like the cosine of the negative 1 with the 3 over 2, would that be like, not the reference angle, but like the answer?
Yes. Because if you take the cosine of 5 pi over 6, it's going to be negative root 3 over 2. All right? Yes, ma'am.
So your answer can only be negative if it's sine, not cosine? You're saying all your answers have to be positive?
Correct. Because you're looking at positive angles. Because cosine starts positive and it becomes negative with an obtuse angle.
Yeah.
Whereas sine's only going to search between 90 to 0, 0 to negative 90,
Yeah.
if you do it that way. Yes, ma'am. Yeah, please, by all means. No, sit down. You cannot walk around.
Why are we finding this as
Instead of this here is your reference. It's just telling you when you're placed here, your opposite's 1, your next to you is the negative root 3. That's where this comes from. And what we're doing is we're figuring out what angle has that sign. So the angle that has that is the angle that has this as a reference angle, which happens to be about 50.
Okay. I think that.
Okay. It'll take a little bit. No worries, no worries. We'll take a couple more examples. Yes, ma'am.
So it can't be negative
No. Cosine is only searching between 0 and 180. Okay? As we open it up later on for list all possible angles, then you can replicate with the
So then it
reference.
would be the 2.
But for now, we're just looking between those two spots. And then the last one is tangent. What angle has the tangent value is what that means. And tangent is similar to what sine does, but it does not include the quadrantal. You're going to search for it between pi over 2 and negative pi over 2, excluding the quadrantal. And the reason is, what's the ordered pair at pi over 2? That's 0 and 1, right? And tangent, if I do tangent of pi over 2, that would equal y over x, which is 1 over 0, which is undefined. You can't take the tangent of 90 degrees. That's why it's undefined at pi over 2, and it's also undefined at negative pi over 2. So you're going to search between those two possible values to give you all the positive and the negatives, and you'll bounce them later on when we add on to solving equations. Okay? I know it sounds weird, and I do a couple examples. I'm pretty sure you'll start to see, oh, that's why you moved it to there. Yep, lots of wrong with you.
So we're not using the quadrant at all?
Nope. Feels left out, but whatever. Let's see, which one was it? So if I do this,
Oh,
yeah.
next week, yeah. We'll do it next week, because then on Friday we'll do our pi down.
Okay, yeah.
Okay. So, example of this is when I just say, hey, knucklehead, what angle has a sine of root 3 over 2? Which means you have to think which of the two triangles has the root 3s. It's either the 45 or the 60. It's the 30-60s, okay? So it being a 30, 60, 90 triangle, and this being positive, that means it has to be in the first quadrant. You okay with that? So when you're looking for a sine value, that means you're placing theta here, and it's always looking at its opposite. which angle looks opposite the root 3?
60.
The 60. So this means this answer is 60 degrees, otherwise known as pi over 3. That's all you're doing. Yep. Ding, ding, ding. Big light bulb fit here. That makes me happy. Hey, tangent does it too. Because think about tangent. You're bouncing between those two. You're going to have a positive coming up reference, negative going down reference. No, you made mine. You have no idea. That's awesome. You got that. You're like,
Yeah.
first quadrant is all reference angle. Oh, holy crap. Did you just say that? Yes, I did. It's true. Okay. I was talking to myself and I was answering my own question. I'm not mean.
So you're just preaching behind.
What'd you just say? All I heard was
What angle has a cosine of 2?
369. No.
What angle has a cosine of 2?
369.
Okay. So cosine, you go between here and here, correct? What's the ordered pair at 0? 1, 0. Okay. 1, 0. What's the ordered pair at 90?
0,
0, 1. What's the ordered pair at pi?
1. Negative 1, 0.
Does anywhere upon that go beyond 1 or negative 1? Can I have a cosine? Can I have any angle's cosine equal 2? No. That's impossible. Cosine values. Cosine values, if you reference again the whole idea of that unit circle, if you think about what happens with cosine, cosine at 0 is 1. When cosine gets to 90, it's 0. When cosine gets to 180, it's negative 1. If cosine gets to 270, it's back to 0. When cosine gets back to 360, it goes back to 1. Again, cosine is an oscillating function, just like sine.
Basically, if you ever get one that's above 1 or below -1, so.
You just say answer is no. Okay.
Inconceivable.
Inconceivable.
Undefined?
No, the answer is no. It's impossible.
If we wrote inconceivable, it has the lead side.
I would probably snicker a little bit and just say,
And then mark it
Just like when I
wrong.
crossed
Yeah.
out.
yeah, I know.
I'd be like,
Forever alone. That was great. Yes,
I
Lavon.
still don't really understand.
Okay. Values of cosine. There is no triangle that we can place in the unit circle that has an adjacent value of 2 and a hypotenuse value of 1.
Oh.
Because can your adjacent value ever be longer than your hypotenuse?
Do they do this for secant and stuff too?
No. Yeah, we will.
Oh, okay.
It's a little bit easier.
Let's say, because you could, wouldn't that
Be-
be technically possible to do the secant?
Yes, because when we do it with secant and cosecant and all those, we take off the idea of within the specific range. We say within a revolution, or we'll say something called general solutions. And then there are all these other plausibilities that happen. What this does, it just gets you in the mindset of how do you figure out which angle you're looking for. That's all this is. Okay. All right, what about this one?
You can't put this, right?
What do you mean you can't do this?
You do it in the bottom part.
No, you can't do it.
Yeah. Because it's not a quadrant. It's just
Well, where do you find tangent?
It's in the fourth quadrant.
In between the
right?
first and the fourth.
In the fourth,
And
and
it's
it's 1 over
including the
1.
quadrant.
Okay. Well, tangent's what over what?
Oh, opposite over.
So tangent's opposite over adjacent, correct?
Yeah, you have
So
one
opposite over adjacent, in order to be opposite and adjacent being equal to 1, doesn't the opposite and adjacent have to be the same? Which means it has to be a 45-degree angle because here's your 1 and a 1, but in this case it's down. So what's your angle? You're right, but it's
Negative.
negative 45.
So it's negative pi over 6.
Very good.
So tangent and sine can have negative, so cosine can have
Yeah, yeah, because what'll happen is it'll say, it'll have negative angle, yes, because they're finding,
Okay, guys, it's the third and the fourth quadrant.
they're finding the reference angles for you for sine and cosine, or for sine and tangent. The cosine is gonna give you an obtuse angle that you have to utilize that reference angle later on.
Okay.
Yes, ma'am?
So how would it equal up to, because you said you can't do quadrant, wait,
Hey, you can do it, you can do you can do the x-axis quadrant.
except for y, what would it look like if they gave you?
Okay. The tangent at 0 is 0 divided by 1. We okay with that? So that's at 0. The tangent at 45 degrees is 1 over 1. The tangent at negative 45 degrees is at negative 1. It does a little weird dancey thing. Because then as you get to 90 degrees, you get an asymptote. When you get to negative 90 degrees, you have another asymptote. Tangent is a non-continuous function because it has vertical asymptotes because you can't divide by 0. You could try to, but you get a black hole of death. As you, I know, it sounds great. Wait, no. As you go through the unit circle looking at tangent values, you start at 0, you get to positive 1, you approach, you're getting closer and closer to an infinite value, and then you get divided by 0, and then you start all over again as you go back and around. Well, you guys are all divided by 0. All right.
Tan -1.
It would, tan negative 1 of 1?
No, I mean like.
Oh, yeah, I know what you mean. All right, so it'd be tan negative 1 of 0.
Oh,
And what angle has a tangent of 0? The right one. Correct. 0. To the right. I see what you mean. It is possible to have tangent of 0.
Oh, wow.
Because
Maybe an extra credit question. Yeah.
tangent's just y over x. That's 0 over 1. There it is. Because it's well within negative root 2, root negative pi over 2. I'm sorry, pi over 2, negative pi over 2.
So well, like I'm saying,
What's that?
What angle is that? That's what it is right now. Wait, I thought you could do the isn't that a quadrangle?
Yeah.
But you can't do the quadrant.
Yes, you can.
You can do the.
Verticals you can. Horizontals you can't. Damn it! Ruby!
I wrote that all down too, like you can't
Oh.
do any of the quadrantals.
No, you can't do the vertical quadrantals because on vertical quadrantals you're dividing by 0. On the horizontal quadrantals you're dividing by 1. Does that make sense?
Yeah, I wrote that in bold. Oh, yeah, in box. Thank you.
exception. It's okay.
Oh my god.
Pork chops.
It has a mole too.
And if you think about it, there's only
It's gonna be a third.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is there only 14 total possible angles and questions I need to ask you on this?
I've got this out. 1, 2, 3, 4, 5, 6, 7.
Well, you have to go up.
There's only a finite, if you start thinking about reference angles, there's 1, 2, 3, there's only 3 reference angles, and there's 3 trig functions. There's 9 possible solutions really to all of these.
So we have 9 homework problems?
Sine negative 1/2, which means you're going to go between
It's gonna be the bottom one.
It's gonna be the bottom one, because it's gonna go negative.
But then how do you know where you just like draw it out like it would be negative?
1 over 2, so it would be a
and
30,
then
60,
down?
90.
No, because sine, remember, is opposite. Sine is y over r. So your sine value you're looking at is 1, down 1, and your hypotenuse is
Right,
2.
because the other one's negative.
Correct. So which angle looks at 1? 30. So this means this angle here is negative 30, or negative pi over 6.
Would it be okay if we thought about it as like y over r and x over y?
Yeah.
Okay,
Because that's perfectly fine, because that's what you're learning about placement, because then you're like, okay, sine is this over this, and that's fine.
Okay, like once like I thought of it as like y over r, that being a lot.
Yep, that's all it is. Okay? Alright, so the other part of this section is stuff that you've already done, and I'm not going to do it, so I'll have you do it. So this is in 13.4. Yeah. Yeah. Okay, we'll do those. The first grouping are all what angle has, what angle has, what angle has. The last 4 are, you'll have to draw the pictures. The last 4 you need the last 5 of them you need a calculator to do them, because you are, make sure you're in degree mode, because they're gonna, it's just a diagram picture of right triangle trig that you have to put things together to find the answers for. It's nothing that you've never done, okay? It's a picture that you'll have to draw and answer the question. You know, dump trunk bed shown as a 10-foot bed when it's tilted the maximum angle. Find the maximum angle when it's 7 feet off the original position. Okay, so you went up 7 feet. You've got a bed of 10. Theta, 10 or 7 over 10. Right triangle trig. So you'll be able to figure out that. Tomorrow, it looks like it won't be a big issue at all to start 14.4. And that's where we start doing the solving of equations. Okay? Yeah. But actually, solving equations is easier than this.
Like it's easier to leave in the circle. But this is like this what we just learned today is easy. Oh, that's not bad.
Yeah, a little reference sheet.
But then you just like think about it in like terms of a right triangle, like 36.
What do you do first to get x by itself?
You add to
Okay.
inverse cosine it. Oh, so that you just have to draw it out. Okay.
And what angle has a cosine of a half? Boom, there's your answer. That's it. But I'll put in, what I'll do though is I'll put in 2 different parameters. All values of theta between 0 and 360. So if there's going to be there's going to be multiple angles that have a cosine value of a half.
Yeah, because like isn't it all the 60 ones that are like
Exactly.
60 up off?
It'd be 60 up, but where's cosine positive? All students take calculus. 0, 1, and 4. So you'll give me my 60, and then you come around and say that's at 300. So it'll be pi over 3 and 5 pi over 3. And that's what you're doing. It's not. But you have to be able to set them up is all you're doing. But then I throw some quadratics into it and all that other fun stuff. Exciting. Yay. You guys don't care. LeBlanc quit though, so.
I just try not to put stuff I'm doing like in the future. Like see this. Like see stuff that we're gonna do in like
Well, that's why I keep trying to put, I try to show you guys why I'm showing you how to do something. This whole idea of graphing. Graphing is a huge chunk of this. But if you understand that it's just oscillation. Is all it is you're going around. You're just oscillating through. So. Oh, big terms. I sound smart when I say them. We all know it's not.